Okay, so in this question here, we're asked to expand 1 plus 4x to the power half to start with, right? So we use the binomial theorem and obviously the expansion of it is in the form of the booklet, and of course you need that for the range, all right? So in this case here, we start off with 1 plus then n, right? And remember n now is the power as it corresponds to that, so that's half. And then your x, and remember your x becomes what we've got here, which is 4x. So we'll put 4x in there. Plus then, well, your n, which is a half, times then your n minus 1. So if I take 1 from that, you get minus a half, over 1 times 2, which is 2. And then you've got to do x squared. Now remember, right, you've got to square the x, but our x has become this, isn't it? So we've got to square all that, so put it in a bracket. Okay, plus then dot, dot, dot. All right? So then we're going to simplify this. So this becomes 1 plus, well, half times 4 is 2, so that's 2x. Now what I would do next is, I wouldn't necessarily work this out in one go on my calculator. I would just do this maybe first. Okay, and if I do that on my calculator, it comes out to be minus 1/8. And then of course you square this, and if I square that, I square the 4 as well, yeah? So I get 16x squared there, plus dot, dot, dot. So this becomes 1 plus 2x, and 1/8 times 16 is well, on your calculator is 2, isn't it? It's 16 divided by 8, and you get that. Okay, so there's your expansion of 2x squared. Don't forget we need to do state the range, okay? So mod x is less than 1, but remember our x became 4x, didn't it? So we have 4x is less than 1. We take the 4 out of the modulus because it's positive, constant. And of course, when we got that then, we can just take the 4 over the other side and divide, because it's 4 times it, take it over and divide. So you've got mod x is less than a quarter. In other words, x has got to be less than a quarter or greater than a negative quarter. As long as the size of it is less than a quarter, so it's within there, you're sorted. Okay. Now, of course, it's the second part here, which can cause some problems. And what you've got to take note here, of course, is binomial theorem, right? Binomial just means 2, yeah? And it works because there's 2 terms in the bracket. And notice now we've got 3 terms, okay, which causes a bit of a problem. All right? But what we can do, this answer we got here, we can actually use, okay? The first part they're expecting us to use, because if you notice with the first part, it's 1 plus 4, isn't it, x? 1 plus 4x. So you've got 2 terms there, haven't you? But if you notice here, 4 is quite sort of prevalent, isn't it? You've got 4 there, okay? And then 4 is actually a factor of 16k squared. So what I want you to do, I want you to rewrite, right? So when we've got this here, I want you to rewrite this. Okay, there's my 3 term, isn't it? It's 3 terms at the moment, and that's no good. We can't have 3 terms. Can't have 3 terms at all. I want us to rewrite this as 2 terms. And how I do that is as follows. I look at what I've got here, this bracket, and I try and rewrite it like that. So what I'll do, I'll start off with 1 plus, yeah? And then notice I got 4 there. So I'm going to write 4 as I've got here. But what I'm going to do then is, I'm going to appreciate 4 is a factor of both of these. So I'm actually going to factorize this here, but I'm only going to take out 4 as a factor because we've got 4 there. I'm just taking 4 out. I could take k out as well, but I don't want to do that, right? It'd be wrong to do that. Just take 4 out like I got here, and then let's do a square bracket, right? So make this a bit bigger. Square bracket. Now what do I times by 4 to get 4k? Of course that's going to be k, isn't it? And then what do I times by 4 to get 16k squared? Well, that's going to be 4k, isn't it? Okay, or 4k squared rather. Okay, so that would give me 16k squared. Bracket then to the power half. Now what I want you to realise now is the appreciation that basically this is just like what I've got above. This is like 1 plus 4, and my x is basically now this, if that makes sense. So I've made these equivalent. I've made them the same. So 1 is this, as we've got the plus there, you've got the 4 there, but my x then is just this double term here. Okay, so all we need to do to get my result is we need to set x to equal to k plus 4k squared, okay, in this expansion here. So then we can say that my result of 1 plus 4k plus 16k squared to the power half is, of course, what I've got here, okay, but if we set then now x to equal this, you just sub it in there, so we have 1 plus 2, okay, that, remember that's my x, k plus 4k squared, take away then, I've got 2x squared, so 2 You've got to square that x, so square that bracket. Now when I multiply this out here, I'll have 1 plus, well, that'll be 2k, that'll be 8k squared. Take away 2, now double bracket here. And what's good is, right, you'll notice here, when I simplify this now, this double bracket, I won't need to write every term, okay, because I've got minus 2 there. When I multiply out, I'll have k times k, which is k squared. And in fact, I don't need to do any other term, because first is k times k, which is k squared. But if I do the outdoors, k times k squared, or k times 4k squared, that'll be 4k cubed. I don't want I don't want any k cubes, because remember the question says, go up to k squared. So I can just ignore all the rest, okay? So I end up having then 1 plus 2k plus 8k squared minus 2k squared. So that will become 1 plus 2k plus 6k squared. Okay, and we've simplified it, and there's our answer.